Hello.
Yes, sir.
Yeah. Can you hear me?
Yes, sir.
Okay. So today we'll look at a little bit of the Euclidean algorithm and then Gauss's lemma, some problems and some concepts. So first of all, here, what this means is you know about calculating GCD of two numbers by this algorithm, right?
Yes, sir.
So basically it depends on this property. Let A and B be integers with B not equal to 0 and let Q and R be the quotient and remainder, be the quotient and remainder when A is divided by B. When A is divided by B, the property depends on, first of all, here when I write it, A is equal to BQ plus R is the relation. So the property depends upon GCD of A and B is same as
Sir,
GCD
your
of
voice is not clearly audible. You are not audible clearly. It is
hello.
stucking in between.
Can you hear me right now? Hello, hello. I think it's an issue with your internet. You need to check. Hello.
Yes, sir. Sir,
I
right.
think it's a problem with your internet or something
Oh,
because
yes, sir.
my
Now
voice
fine.
is fine. Uh,
Huh.
so the algorithm depends on this property that GCD of A and B is the same as GCD of B and R, right?
Yes.
Because of this, you can go down and keep doing the same process again and again in order
Hmm.
to find the GCD,
Yes,
right?
sir. Yes,
Now,
sir.
how do we prove this? We can say that any common divisor of A and B also divides R and B.
Hmm.
Also divides R and B. Obviously, it's a common divisor of B, so it will always divide B, but it also divides R because A minus BQ is equal to R.
Yes, sir.
And if it's a common divisor of A and B, then that number divides this part and also divides this part. So
So it has to
clearly,
divide.
yeah. So it has to divide
Hmm.
R, right?
Yes, sir. Hmm.
So that is the first thing. Then you can also say that any common divisor of B and R is also a dividing A, dividing A and R.
Hmm.
Why? Same reason. If it's a common
Yes, sir.
divisor of B and R, then it will divide A also.
Hmm.
So basically, what we can say is that any common divisor of B and R will be a common divisor of A and B, right?
Hmm.
So basically, you can say that these common divisors will divide each other, right?
Yes, sir.
And since they are positive integers, these common divisors, if they divide each other, then they have to be equal.
Yes.
The way to prove equality in number theory is that you say A divides B and B divides A.
Hmm.
That implies A is equal to B, right?
Hmm.
We are using that property. We are saying that a common divisor of A and B will divide a, a common divisor of B and R. And
Hmm.
similarly, a common divisor of B and R will divide this, right?
Yes. Hmm.
So that's how you're showing the equality. And once you are getting that, you can do the algorithm. For example, suppose you want to find out, let's say A was 4,284 and B was 3,480, and you want to find out GCD of A and B.
Hmm.
So you will do one step of the algorithm by dividing A by B. You'll say 1 into 3480 plus 804, right?
Yes, sir.
But we know that GCD of A and B is the same as GCD of B and R.
DNR.
Here, this is A, this is B, this is Q, this is R, right? So if
Yes,
I
sir.
wanted GCD of A and B, these two numbers, it's the same thing as GCD of B and R, 3480 and 804, right? So I'll now do
Yes,
the
sir.
same thing on 3480 and 804. So it will be 4 times 804 plus 264, right? Now
Hmm.
this has become the new A, this has become the new quotient, right? Divisor.
Yes. Now we
So
have 804 and 264.
so now we have 804 and 264 after this, right? We can say 804 is equal to 3 into 264 plus 12. And finally, you'll say 264 and 12 now. So
Hmm.
264 is equal to actually 22 into 12 plus 0, right?
Hmm.
So at the end, you're getting remainder is coming as 0 here, right?
Yes, sir.
The last remainder in this process is 0. Our
Hmm.
GCD will be the last non-zero remainder.
Hmm.
Last non-zero remainder will be the GCD.
Hmm.
Do you understand what I'm saying?
Yes, sir.
So we are following the same identity. We are applying multiple times here once, then here, then here, then here, right? Correct.
Yes, sir.
So that is the Euclidean algorithm. Now you can also say that we had learned earlier that GCD of A and B can always be written as AX plus BY, where X and Y are
Hmm.
integers.
Yes.
We had seen that earlier in one of the classes, right? So
Yes, sir.
now, if I wanted GCD of 4284 and 3480, I have already found it is equal to 12, right?
Hmm.
So I should be able to write it as 4284 into X plus 3480 into Y, right?
Hmm.
There should be X and Y such that I can find this equation to be true, right?
Yes, sir.
So how do we find these X and Y? Basically, you have to work backwards now, right?
Hmm. Hmm.
So you will say from here 12 is equal to 804 minus 3 times 264, right?
Hmm. Hmm.
And now 264 we can write as 3
Four
times
times.
3480 minus 4 times 804,
Hmm. Hmm.
right? And
Yes, sir.
then 804 we will replace from here.
Hmm.
Notice that 804 has come multiple times now.
Ah.
You will get 12 is equal to, so far you have gotten
5.
12 plus 1, 13 times 804, right?
Oh, okay.
Minus
Yes.
3 times 3480, right? And for 804, I will write 42804, 4284 minus this, right?
Hmm.
So 13 times 4284 minus 13 times 3480. So minus 16 times 3480, right?
Hmm.
So finally, we are able to recreate and say that 13 is X and minus 16 is Y.
Ah.
Do you understand what I'm saying?
Yes, sir.
So that is one way in which uh, we are able to produce the numbers x and y such that GCD AAB is always AX plus BY, right? You have to run
Hmm.
the Euclidean algorithm in reverse. First, you have to do it, and then you have to go back, reverse the steps.
Hmm.
Is it clear?
Yes, sir.
Okay, then try this question first. Uh, prove that for all integers a greater than 1 and n greater than equal to 1, we have GCD of a power n minus 1 by a minus 1, comma a minus 1 is equal to GCD of a minus 1, comma n. Try this out first. Basically, this is something that we can factorize, right?
Hmm.
You should know that this can be written as summation
A
j
minus.
goes from 0 to n minus 1 a power j. That is the factorization. This is what? This is a power 0 plus a power 1 till a power n minus 1. If you multiply this with a minus 1, it will be equal to a power n minus 1.
Okay. Huh. Huh.
You can check it for any n. It is
Yes, sir.
correct.
Yes.
This is an
Hmm.
identity that you need to know. X power n minus y power n is equal to
Huh.
x minus y times.
Huh.
Starts off with x power n minus 1, then x power n minus 2 y plus x power n minus 3 y square, and so on goes on till y power n minus 1. Right?
Yes, sir.
So we can write this as a summation. And now what we will do is we will change it a little bit. We'll write it like this. Summation j goes from 0 to n minus 1. A power j minus 1 I'm adding to the summation. So automatically you should realize that that is n terms. So you have added minus n, right?
Hmm.
So you can
Hmm.
do a plus n, right?
Yes. Hmm.
So now think about it. Each of these, each of these is a multiple of a minus 1.
Huh.
You start off with 0, but as soon as you do j is equal to 1, you get a minus 1. Then j is equal to 2, a square minus 1 is a multiple of a minus 1.
Hmm.
All of those
Hmm.
are divisible by a minus 1, right?
Huh.
So this whole summation is can be written as some k times a minus 1, right?
Yes, sir.
For sure, every term in it is divisible by a minus 1,
Hmm.
right? So what
Yes,
we
sir.
have been able to do is we have been able to express this thing as some k times a minus 1 plus n, right?
Oh, oh, and we are done.
So now when we do GCD of this thing with a minus 1, we have to do GCD of k into a minus 1 plus n with a minus 1, right?
Mhm.
So automatically k इन दोनों का GCD क्या होगा? It will be the same as the GCD of n into
A minus
a
one.
minus 1,
Uh,
right? Because the GCD
yes,
of this and so how do you understand this? You can say
yes,
that,
sir.
tell me.
ए और ए बी का जो जीसीडी होगा वो इक्वल होगा ए और बी प्लस समथिंग इनटू ए,
Right, so
बी
you're
इनटू
saying
समथिंग
a
प्लस।
plus kb comma b. The
हाँ,
GCD of this is same as GCD of ab,
ए बी। हाँ,
right? Because this is a
यस।
multiple of b, it doesn't affect the GCD process, right?
हम्म।
So that is what you are saying, and we have the proof now,
यस,
correct?
यस सर।
Okay, another question that we'll look at is this: find infinitely many integer solutions to the equation 15x plus 21y plus 35z equals 1. So try it out. Think about how you can get the solutions. The hint is that these two have a common factor of 3.
हम्म।
If you write 3 into 5x plus 7y, you can write that as 1 minus 35z, right?
यस सर।
So that means that this number is divisible by 3 somehow,
ओके।
right?
हम्म।
So if you think of z as mod 3 in terms of z mod 3, if you think, right? how can it be divisible by 3? The 1 minus 35z has to be divisible by 3, right? If it is 0 mod z, mod 3z, it won't work, right?
नहीं,
If it is 1 mod 3, it
it
still
will
won't
work.
work.
Oh no,
No.
no. It
Minus
has to
34
2.
are,
हाँ
right?
हाँ, -1 will work.
So it has to be 2, right?
Yes, -1 is 2. Yes.
Z has to be 2 mod 3 for sure, correct? So now
Yes,
if
sir.
I put Z as 3t plus 2, something like that, in this equation, what am I getting? 1 minus 35 into 3t plus 2. I'm getting minus 70, so minus 69 and 105. Minus 105 t minus 69, right? And I can cancel the 3 now from both sides. And I am getting 5x plus 7y is equal to minus 23 minus 35t. Correct?
Yes, sir.
Okay. Now we have to think 7. Like we can try to guess at least some root.
सर एक सॉल्यूशन तो एक्स वाई जेड का दिख गया था,
So
ऑब्वियस.
basically, you can say 7 is 5 into 1 plus 2. So 5
सर एक तो
into,
x=1, y=1 और z=, -1.
not in the original. I am looking at
ओके,
this
इन दी.
equation right now. Think of this equation. No? We have simplified stuff.
हाँ
Think of solutions to this equation. So if you think of 7 as 5 into 1 plus 2, uh, wait 1 second.
सर x1 y1 एंड t-1.
Basically, we can start by doing t is equal to -1 and then or 0 and see what are the possible solutions for x and y. And yeah, so if t is equal to 0, we are getting 5x plus 7y is equal to minus 23, right?
यस सर.
There will be infinite solutions for this. Uh,
इसे तो निकाल सकते हैं.
you can put anything. X is 1, then y is going to give something, right? No, there's it will become a big solution, right? Feel like I'm making a mistake somewhere. 1 minus 35 into 3t plus 2, we are getting, oh, minus 23 minus 35t. Okay, so, okay, I'll do it on the next page. 5x plus 7y is equal to minus 23 minus 35t. And we have 5 into 3 plus 7 into minus 2 is equal to 1. 5 into 3 plus 7 into minus 2 is 1. But then you'll get 24 is equal to minus 35t. Okay, so we had earlier what? 3 into 5x plus 7y is equal to 1 minus 35 into 3t plus 2,
35 Z. ओके हाँ.
right?
हम्म.
So 3 into 5x plus 7y plus 35 into 3t plus 2 is equal to 1 was the equation. So okay, so
फिर ऐसा अगर 5x 7 और 3t2+2 को एक सिंगल वेरिएबल लेके चले तो उससे कुछ हेल्प होगा. और तो वो 3 सम ए प्लस 35 इंटू सम बी इक्वल टू 1 ऐसा आएगा. और उसका वो भी 0 है, मतलब 0 1 है 3 और 35 का जीसीडी.
हाँ, 3 और 35 का GCD 1 है.
हाँ.
5x plus 7y and 3t plus 2. So these are some integers,
हाँ.
right?
हाँ.
Hmm. मुझे कोई एक प्रोसेस नहीं समझ में आ रहा है कि we can get all the solutions. That's what I'm trying to get. Some process by which we don't have to just guess.
हाँ.
Guess करके solutions तो आ ही जाएंगे, उसमें कोई doubt नहीं है.
हाँ.
But we need to
तो
have a general way to get all the solutions.
हम्म.
Okay, so for the general way, we already know z is 3t plus 2.
हम्म.
So is it possible for all values of t to get 1, 1, x and y? I think it should be possible. So if you put t is equal to 0, z is equal to 2. If t is 0, what is happening to this equation? We are getting 5x plus 7y is equal to minus 23.
-23.
Now, one way to quickly solve it would be if you do mod 5 here, right?
हाँ.
So this will be 0 mod 5, this will be 7y mod 5 is congruent to this is minus 3 or 2 mod 5, right?
2 mod 5.
So that will tell us that this 7y has to somehow be 2 mod 5, right?
y इक्वल टू 1.
7 क्या होता है? 7 is 2y
हाँ.
mod 5, right?
हाँ.
Congruent to 2 mod 5. And since
हाँ.
2 and 5 are co-prime to each other, relatively prime, we can divide by 2.
हाँ.
So y is congruent to 1 mod 5,
ओके.
correct?
यस सर.
Do you understand what I'm saying?
हाँ. हाँ.
Y should be congruent to 1 mod 5, right?
1 mod 5.
So we have a hint right now कि क्या होना चाहिए. It could be 6, for example. It could be 11, right? Similarly, we can do mod 7 and get for x also, right?
x. Yes.
5x mod 7 should be congruent to minus 2, which plus 5 mod 7, right?
हम्म।
-23 क्या आ रहा है? -2 mod 7, which is +5.
हाँ,
Now 5 and
प्लस
7 are co-prime, we can cancel 5. This
इफ
operation cannot be
वन
done unless they are co-prime, right?
ओके। हाँ।
So x is coming as 1 mod 7 also,
हाँ।
right? So x could be,
यस।
now we only have to check those types of numbers, correct?
हाँ।
So for x, we will check 8, we'll check 15, we'll check 22, and so on. For y, we will check 6, we will check uh, what? 11, and so on, right? And also negative ones, right?
हाँ,
Correct? No?
इंटीजर्स।
Because
यस
we
सर।
need to make it in, we have to check negative integers,
यस।
right? So,
हाँ।
1 mod 7 में पिछला वाला क्या आएगा? 1, और उससे
वन।
पिछला वाला है -6, right? Correct?
यस सर।
Then
नीचे
-7,
में।
-13 and all.
हम्म।
Correct?
हाँ।
Those are for y, right?
यस। नो, एक्स।
This was
मॉड
this was
7
for
वाज
x, huh? This was for x, right?
हाँ।
And for y it
मॉड
was this, and then it will be 1, and then
1,
-4,
-4, -9।
-9, -14 and all, right?
हाँ।
-14, -19, -24, right?
हम्म।
So one of the answers that comes is -24 for y, and for x comes out to be, if you go ahead, it is 29 and 36. X is 36 and z is 2. Oh, no, z is not 2. Z is 3t plus 2, right? So it could be 2, it could be -1, or it could be 5, and so on, right?
हम्म।
Correct? So z ka
हम्म।
-1. So basically
हाँ।
you fix z ka one value and then start looking for which ones will satisfy, right?
हम्म।
You can see in the original equation 15x plus 21y plus 35z is equal to 1. Z is -1, -35.
-1 में तो एक्स एक्स और वाई 1 आ रहा है ना।
किसमें?
अगर z -1 रखेंगे तो एक्स और वाई 1।
कैसे?
z
वहाँ 1 भी
-1
आ रहा
तो।
है। 1 भी आ रहा है, बट
हाँ, तो सेम वैल्यू पे दो हो सकते हैं।
1 second, लेट मी जस्ट चेक। 15 इंटू 36 क्या हो रहा है? 360 and 180, 540, right?
+180। हाँ।
And 21 minus 24, so 480 and 21 24 उसमें 504, right? तो +36 आ रहा है, right?
हाँ। हाँ, ये भी।
And z is -1 is also fitting,
ओके।
correct?
ओके। हाँ।
So basically you'll get many solutions. The point is that this question we have right now done by doing mod 3, mod 5, mod 7, right?
हाँ।
We are getting all the possibilities. Notice the steps by which I concluded these.
हम्म।
But still, like, I'm not very satisfied because this is still very
मतलब
annoying.
ऐसे नहीं कह सकते ना कि इसके जितने जनरल वाले आ रहे हैं वो सारे हो जाएंगे सॉल्यूशंस।
Uh, सारे हो जाएंगे क्या? I don't think so.
हाँ, मतलब
I think we don't
एक्स
have a
की
gen.
वैल्यू पे।
We still don't have a general process
हम्म।
to get all the
हम्म।
solutions. Right now, we have just
हम्म।
gotten one possible solution, and we
हम्म।
can get more, but we have not gotten the main idea. समझ में आ रहा है मैं क्या बोल रहा हूँ?
हाँ सर।
अभी फुली हुआ नहीं है ठीक से। I'll have to think
नहीं।
about it. क्योंकि इसमें तो बहुत टाइम रहेगा ना, इसमें सर्च करना पड़ेगा।
हम्म।
Okay, anyway, we'll come back to it later. I
हम्म।
wanted to mention couple of things also. Gauss's lemma. So it says if A, B, C are integers, A, B, C are integers such that A divides BC and GCD of A and B is 1, then A divides C. Now, it seems like an obvious statement. The proof is obvious. Because of this statement, we know AX plus BY is 1,
हाँ.
where X and Y are integers, right?
हम्म.
So, we know this A divides BC. A divides BC. So we can write here multiply by C both sides. AC X plus BC Y is equal to C, right?
हाँ.
And we know
हम्म.
that A divides BC, and obviously A will divide this. So that means A divides C.
Yes sir.
Do you understand what I'm saying?
Yes sir.
From here we got this condition. From here, so here we multiplied by C on both sides. We got this equation. And because
हम्म.
A divides BC, I know A is a common divisor for both of the terms, right? So
हम्म.
A must also divide C, right?
Yes sir. हम्म.
So now we will use this kind of logic to solve some problems. For example, this question, positive integers A, B, C satisfy A cube times 3A plus 1 is equal to B square times B plus 1 whole cube is equal to C, and GCD of A and B is 1. Your job is to find C. Try it out.
हम्म.
You have to use Gauss's lemma intelligently here. So think about it. Here we are given that they are equal, right? A cube into this, these two numbers are equal. So that means this number divides this and this number divides this, right? Do you understand what I'm saying?
Hmm.
So we can say that a cube into 3a plus 1 divides b square into b plus 1 whole cube, right?
Hmm.
So obviously that will mean since 3a
Three
plus
plus.
1 and this are co-prime,
हाँ.
they are relatively prime because a and b are relatively prime.
Hmm.
We can say from here that a cube divides b square into b plus 1 whole cube.
Hmm.
Okay, and we know that GCD of a and b is 1. So that means a cube cannot divide b square, right?
Hmm.
So a cube should divide b plus 1 whole cube, right?
हाँ.
And that will mean that a cube is less than equal to b plus 1 whole cube.
Hmm.
And that will mean that a is less than equal to b plus 1.
Hmm.
Correct? Similarly, you can say b square divides a cube into 3a plus 1, right?
Hmm.
And GCD of b and a is 1, so b square divides 3a plus 1. Correct?
Yes.
Applying Gauss's lemma, it is cannot divide a cube.
हाँ.
So it has to divide this, right? So which means
Hmm.
b
Hmm.
square is less than equal to 3a plus 1, right? So now here, from here and here, we'll combine them. We'll say b square is less than equal to 3 times. Instead of a, we can say less than equal to. We can say less than equal to 3 times b plus 1, right?
Hmm.
Because a is less than equal to b plus 1.
Hmm.
So we are getting this inequality. B square is less than equal to 3b plus 4, right?
Hmm.
So this can be factorized. B plus 1 into b minus 4 is less than equal to 0. From where we get b is less than equal to 4, right?
Hmm.
It's also greater than equal to minus 1,
हाँ.
correct? Now
Yes, sir.
you just do all the cases for b being positive integer. So you can take b is equal to 1, 2, 3, 4, right?
Yes, sir.
You can check those cases. If you check the case for b is equal to 4, you will get a solution. If b is equal to 4, you will get a solution for a. A will be 5. You can see 16 into 5 cube is equal to a cube into 3a plus 1, right? It is obvious that 5 will satisfy.
Hmm.
So you're getting a is 5, b is 4, and from there you'll get c is 2000.
हाँ.
So the point is, when two numbers are equal, you can say one of them divides the other and the other divides the other one, the first one, right?
Hmm. Hmm.
And because of the GCD stuff, we were able to say that if a cube into 3a plus 1 divides this, so a cube divides this, and then from there we can say a cube divides this. And we got
हाँ.
an inequality. Similarly, we did the other thing for b square dividing this, and we got another inequality.
हाँ.
Okay, there are a couple of
Yes.
questions you can try for homework. Question 1 is this. Let x, y, z, and t be integers such that xy is equal to zt. Prove that there exist integers m, n, p, q such that x is equal to mn, y is equal to pq, z is equal to mp, and p is equal to nq. We have to prove this, okay? That
हम्म,
whenever this is equal, then we can always find integers which will be like this.
हाँ,
Okay. Second question is, suppose n is greater than 1 and r, s, t are non-zero integers such that r power n is equal to s power n times t. Then show that t is an nth power, obviously of some integer,
हम्म,
and s divides r. So try out these two questions. We will continue from this point in the next class. We have to do some more questions on Gauss's lemma and see how it can be applied in problems. And then
हम्म.
we'll go ahead to more theory, new theory.
ओके
Okay, fine.
सर.
That's all for now. Yeah,
सर वो वाला जो क्वेश्चन था वो 5x वाला वो किस
hmm.
सोर्स का था?
It's from T2 Andrescu's book.
ओ, ओके. और सर मुझे पूछना था, मतलब जैसे मैंने इंटरव्यूज में देखा है कि एओपीएस का बताते हैं, तो उस पे
Hmm.
मतलब इतने सारे सवाल हैं, तो मैं किस तरह से उसको यूज करूँ अपने लिए?
तुम पर्टिकुलर एग्जाम के प्रीवियस ईयर्स क्वेश्चंस को सॉल्व करने के लिए यूज कर सकते हो, जो भी एग्जाम का तैयारी कर रहे हो. You can't
ओके.
do randomly, no? You
हाँ.
have to do particular exam papers and you can see the discussions. There are most of the exam paper questions you'll see there will be discussions and solutions.
हम्म.
You can try the question yourself and see the discussion after that to learn.
हम्म.
That's how you use it.
ओके. थैंक यू सर.
Hmm. Okay.